National Electrical Code Article 210.19 A2 states the number of circuit breakers shall not exceed the number of spaces provided in the panel board or other group enclosure. Article 240.82 specifies where multiple circuit breakers are installed in a common enclosure, the sum of the current ratings of the circuit breakers installed in the enclosure shall not exceed the ampacity of the supply conductors. NFPA 70E Standard for Electrical Safety in the Workplace, Section 120.5 states the number of circuit breakers installed in a common enclosure shall not exceed the manufacturer's specified maximum number for that enclosure. Electrical panel manufacturers typically specify the maximum number of breakers that can be installed in their panels. The NEC and NFPA 70E do not limit the number of breakers on a circuit based on the circuit's ampacity. However, it is good practice to keep the number of breakers to a minimum to avoid overloading and potential overheating. The manufacturer's instructions should be followed to ensure that the panel is not overcrowded and that the breakers are properly rated for the circuit. The location of the panel and the accessibility of the breakers should also be considered when determining the appropriate number of breakers. To further elaborate on NEC Article 210.19 A2, it's critical to understand the implications for practical applications. This article isn't just about physical space, it's about ensuring that the electrical panel isn't overloaded and that each circuit has the necessary protection. For example, if a panel board has 20 spaces, you cannot install more than 20 single-pole circuit breakers or the equivalent combination of single and multi-pole breakers. This limit is in place to maintain safety standards and prevent overheating due to excessive current draw. Moving on to NEC Article 240.82, this section deals with the cumulative current ratings of breakers within a common enclosure. If multiple breakers are installed, their combined rating should not exceed the ampacity of the supply conductors feeding the enclosure. For instance, imagine a subpanel fed by a cable with an ampacity of 100 amps. The sum of the ratings of all breakers in that subpanel should not exceed 100 amps. This is to protect the supply conductors from being overloaded, which could lead to insulation failure and fire hazards. Now considering NFPA 70E Section 120.5. This standard emphasizes the importance of adhering to manufacturers' specifications regarding the maximum number of breakers. Manufacturers design their panels with specific thermal and physical limitations in mind. Exceeding the recommended number of breakers can compromise the panel's ability to dissipate heat effectively, potentially leading to premature failure or even hazardous conditions. Always consult the panel's documentation or the manufacturer's website to ascertain the maximum allowable number of breakers. Manufacturers' instructions provide critical details that go beyond the NEC and NFPA 70. These instructions often include specific torque requirements for breaker connections, recommended wire sizes, and environmental considerations for panel installation. Ignoring these instructions can void warranties and compromise the safety and reliability of the electrical system. Always thoroughly review the manufacturer's instructions before installing or modifying an electrical panel. When discussing the additional considerations, it's important to recognize that the NEC and NFPA 70E set minimum standards, and good electrical practice often goes above and beyond these requirements. While the NEC and NFPA 70E do not explicitly limit the number of breakers based on circuit ampacity, it's wise to minimize the number of breakers on the single circuit to reduce the risk of overloading. For example, if a 20-amp circuit is feeding multiple outlets and lighting fixtures, consider splitting the load onto two separate 20-amp circuits, each with its own breaker. This reduces the likelihood of overloading a single circuit and tripping the breaker, which can be inconvenient and potentially dangerous. Furthermore, the location of the panel and the accessibility of breakers are critical factors in determining the appropriate number of breakers. Panels should be located in easily accessible areas that are free from obstructions and environmental hazards such as moisture or extreme temperatures. Additionally, the breakers should be readily accessible for inspection, testing, and maintenance. Overcrowding a panel can make it difficult to access breakers, potentially delaying critical maintenance or emergency operations. In summary, limiting the number of breakers on a circuit is not solely dictated by the NEC or NFPA 70E but also by manufacturers' instructions and sound electrical practices. Always adhere to the NEC, NFPA 70E and manufacturers' guidelines to ensure the safe and reliable operation of electrical systems. Proper planning, installation, and maintenance are essential for preventing overloading, overheating, and potential electrical hazards. It's also important to consider the long-term needs of the electrical system. As technology evolves and energy demands increase, it may be necessary to add circuits or upgrade existing ones. Planning for future expansion can prevent overcrowding and ensure that the electrical system can meet the evolving needs of the facility or building. This might involve installing a larger panel than currently required or providing additional conduit runs for future wiring. Remember, a well-designed electrical system is one that is not only safe and reliable but also adaptable to future needs. Also, regular inspections and maintenance are essential for identifying potential problems before they escalate. Check for loose connections, damaged wiring, and signs of overheating. Use thermal imaging cameras to detect hotspots that may indicate overloaded circuits or failing components. Implement a preventive maintenance program that includes periodic testing of circuit breakers and other critical components. Proper maintenance can extend the lifespan of electrical equipment and prevent costly downtime. When working with electrical systems, safety should always be the top priority. To energize circuits before working on them, use appropriate personal protective equipment such as gloves and eye protection, and follow lockout/tagout procedures to prevent accidental energization. If you are not qualified to perform electrical work, always hire a licensed electrician. Electrical work can be dangerous, and mistakes can have serious consequences. In addition to the technical aspects of limiting breakers on a circuit, consider the regulatory requirements and compliance standards that apply in your jurisdiction. Local building codes and electrical regulations may impose additional restrictions or requirements beyond those specified in the NEC and NFPA 70. Consult with local authorities or qualified electrical inspectors to ensure that your electrical installations comply with all applicable regulations. Compliance with these regulations is not only a legal requirement but also a critical factor in ensuring the safety and reliability of electrical systems. Also, consider the importance of documentation and record keeping. Maintain accurate records of all electrical installations, including panel schedules, wiring diagrams, and equipment specifications. These records can be invaluable for troubleshooting problems, performing maintenance, and planning future upgrades. Keep these records in a safe and accessible location and update them whenever changes are made to the electrical system. Proper documentation can save time and money in the long run and help ensure the continued safe and reliable operation of the electrical system. The selection of circuit breakers is also a crucial aspect of electrical safety. Choose breakers that are properly rated for the circuit and the equipment they protect. Consider factors such as the interrupting rating, which is the maximum fault current that the breaker can safely interrupt, and the trip characteristics, which determine how quickly the breaker will trip under overload conditions. Use only UL-listed or equivalent certified breakers to ensure that they meet industry safety standards. Never use undersized or improperly rated breakers, as this can compromise the safety of the electrical system. Also, think about the impact of harmonics on electrical systems. Harmonics are distortions in the electrical waveform that can cause overheating of conductors, transformers, and other equipment. Nonlinear loads such as electronic ballasts, variable frequency drives, and computers can generate harmonics. Use harmonic filters or other mitigation techniques to reduce the impact of harmonics on the electrical system. Regularly monitor the harmonic content of the electrical system and take corrective action if necessary. Furthermore, consider the use of arc fault circuit interrupters, or SIs. SIs are special types of circuit breakers that are designed to detect and interrupt arc faults, which are a common cause of electrical fires. SIs are required by the NEC in many residential circuits, particularly those that serve bedrooms and living areas. Consider installing SIs in other areas as well to provide enhanced protection against electrical fires. Remember, arc faults can be difficult to detect with conventional circuit breakers, so size can provide an extra layer of safety. Additionally, consider the use of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect people from electric shock by detecting ground faults, which occur when current leaks to ground. GFCIs are required by the NEC in many locations, including bathrooms, kitchens, and outdoor areas. Install GFCIs in all locations where there is a risk of electric shock to provide maximum protection. Regular testing of GFCIs is also important to ensure that they are functioning properly. Finally, remember that electrical safety is an ongoing process, not a one-time event. Stay up to date on the latest codes, standards, and best practices. Attend training courses, read industry publications, and participate in professional organizations. By continuously improving your knowledge and skills, you can help ensure the safety of yourself and others. Also, foster a culture of safety in your workplace. Encourage employees to report potential hazards, provide regular safety training, and enforce safety rules. By creating a safe working environment, you can reduce the risk of accidents and injuries. To reiterate all of the points, firstly, the National Electrical Code Article 210.19 A2 mandates that the number of circuit breakers must not exceed the available spaces in the panel board or enclosure. Secondly, Article 240.82 stipulates that when multiple circuit breakers are installed in a common enclosure, their combined current ratings should not surpass the supply conductor's ampacity. Thirdly, NFPA 70E Section 120.5 emphasizes adherence to the manufacturer's specified maximum number of breakers for a given enclosure. Fourthly, electrical panel manufacturers provide specific limitations on breaker installations in their products. Fifthly, while the NEC and NFPA 70E don't directly limit breakers based on circuit ampacity, minimizing the number is a good practice to prevent overloading. Sixthly, always follow manufacturer's instructions to ensure proper panel configuration and breaker ratings. Seventhly, consider panel location and breaker accessibility for safety and maintenance. Eighthly, planning for future electrical needs is crucial to avoid overcrowding panels. Ninthly, regular inspections and maintenance are essential for identifying and addressing potential issues. Tenthly, prioritize safety when working with electrical systems and seek qualified professionals for electrical work. 11thly, compliance with local codes and regulations is mandatory for all electrical installations. 12thly, maintain thorough documentation of electrical systems for troubleshooting and future upgrades. 13thly, select circuit breakers with appropriate ratings and certifications. 14thly, address harmonics in electrical systems to prevent equipment overheating. 15thly, use arc fault circuit interrupters of size for enhanced fire protection. 16thly, install ground fault circuit interrupters, GFCIs, to safeguard against electric shock. 17thly, stay informed about electrical codes, standards, and best practices through continuous learning. And finally, foster a safety-conscious work environment to minimize accidents and injuries.